Hello everybody, welcome back. So here's our next part on this video. Where we left off on the last one was that we were only getting output from one channel. So what we want to find out is, are we losing our signal at the amplifier, or are we losing it at the preamplifier or line stage? And so in order to do this, there's a lot of ways you can do it, but this is the simplest for me. I'm just connecting my scope to the inputs. So these two little coax cables come from your volume pot, line stage, whatever, the preamp. So this is the input to both channels of the amplifier. And I just tacked a couple little pieces of wire on there to be able to connect the scope, which is real simple. And we're just going to see if we have a Gazintu. And we're just going to see if both channels are receiving a drive signal. Now, one thing you have to understand when you're using these ×10 probes, they're very high impedance. So when you're looking at very low voltages on an oscilloscope, one drawback of a scope is that very low voltages, very low signals through a ×10 probe is going to cause noise, but it's also going to give you isolation between your test equipment and the circuit. So we don't really care a whole lot about the noise. We know what we're doing, we know what we're getting into here, so we can ignore the noise. Now, let me go into the scope here. There are a few things we can do to at least reduce the noise as much as possible. And one thing we can do is on a higher bandwidth scope, you can go to our bandwidth control and we can limit the bandwidth. And if you notice, that does reduce some of the noise. See that? Won't reduce at all. If this had the capability of lowering the bandwidth down to kilohertz instead of megahertz, it would be even better. But you can see I don't even have the unit plugged in, so this is not picking up any interference from the amp whatsoever. This is just the probes being connected in there. So let me plug in. And let's turn it on. And I have a signal, the same signal, being driven into the auxiliary inputs. And you can see we don't have that capacitive coupling right here because this is the input of that decoupling cap. So you can kind of see I'm set to AC coupling. If we go over here, you can see. So if not, there's actually a DC offset on this signal, and we would not see our signal. So channel 1, watch what happens when I go to DC. It goes right off scale. So check out some of my videos on oscilloscopes if you want to know more about coupling. Alright, here we go. Let's turn the volume up. And what we should see is we should see both channels with the 1 kilohertz sine wave as I turn the volume up. And as you can see, and this is what I suspected, channel 1 has a signal on it, and it's not syncing properly because it's such a tiny signal. But channel 2 has nothing. So again, I don't believe there's a problem with the amplifier. I think both channels of our amplifier is working. Now I can take it a step further if I wanted to, and I could inject a signal into both channels to make sure that other channel is working, but really none of that matters until we find the problem why our preamp doesn't have any signal coming out of it. I have a feeling when we fix the preamp, we'll also get our other channel back at the main amplifier. So let's work our way back through the schematic. So let's take a little gander at our schematic. If we look here, we're plugging into the auxiliary inputs, which is here and here. And if you just follow one of the lines, you can see it goes over to this tape monitor switch, comes out of the tape monitor switch, goes through the selector switch here, comes out of the selector switch and goes into the tape monitor switch right here. And then it comes out of that and goes through the mode switch. Okay, that's what this one is. And then from the mode switch, it goes directly into our balance and volume controls. So we can eliminate this whole circuit by putting our meter or our scope on the wiper of the volume pots. This is volume, so this is a dual gang pot, meaning your volume control is actually two individual pots for right and left channel, and they're ganged together, joined together by the same shaft. So they're both on the same knob. So if I put one channel of my scope on this wiper and one channel on this wiper, I should be able to, because it's just a direct, without, you know, other than going through these switches, it's a direct connection from our input jacks to the volume control. There's no active components in there other than these mechanical switches. So that's what I've done. And you can see over here, here's our potentiometer, and you can see the right and left channels, and they're connected together through your volume pot. And I'm just looking at the wiper of this pot and the wiper of this pot with the two channels. And if we move our scope over to our scope here, I don't even need, because there's no electrical circuitry in there, I don't even need to plug the amp in or turn it on to test this. Just feeding the signal into the auxiliary jack, the volume control should work. So if we rotate our volume control, you can see that one channel is actually showing a signal, but the other channel is not. So back to our schematic. What that tells us is we really don't, at this point in time, need to even worry about the little preamp, this little buffer amp here, because we were originally testing right here, you know, where the signal was going into the main amplifier module. If we don't have anything going in here, you won't have anything coming out, so we've just kind of ruled this temporarily out. We have to resolve our problem here first, which may fix the problem. You know, there may be nothing wrong with this, and we don't have to even get into the circuitry here. So what do we do? Well, the first thing I'm going to do is I'm going to move these connectors, or I mean these switches, to see if we have a dirty contact. So we'll turn our volume up, we'll look at our signal on the scope, and I'll move these switches back and forth to see if we get any kind of signal whatsoever. Maybe we'll luck out and it's just a dirty contact. Okay, so the first thing we're going to do is I have the volume turned all the way up to maximum, and I'm going to move the tape monitor switches. So I'm just going to flip tape monitor off and on. And look at that. This switch is bad. And you can, now I've totally lost the signal. There it is, now it's back. But look, it's the other channel now. Now we've lost the right channel and we've gotten the left channel back. I haven't moved anything on the probes or anything. And you can see now I just turned it off and back on, and they're both gone. So let's look at this switch a little more closely. Okay, to clean this, we're going to use our CRC QD contact cleaner. This is very inexpensive stuff. It's quick drying. Let's see if we can see. Quick drying, leaves no residue, plastic safe, and it leaves no residue. That's the most important thing. So this is our first step when we clean a control. And all I've done is I've taken one of these little cards, little note cards, and I just cut some little strips out of it like that. Yes, they make burnishing tools, but burnishing tools actually are abrasive, and we don't want, if there is any plating on these contacts, we don't want that thin plating to, we don't want to sand that off. We want to leave it on there. We just want to clean the tarnish that's on there. If you have to sand it down, you do, but so we're just going to take and put a little squirt of this like that and soak that. Then we're going to put a little shot of it in here, and we're just going to work this control. So we're going to put this in here, close it, pull out. And it's actually clamping on there pretty tightly. I can actually feel it. You can see I can't push it in. It only pulls out because it's actually making very good contact. It's just that tarnish. And just after doing that a couple of times, there it is. We have a signal. Now, as you can see, the signal is somewhat distorted, and that has nothing to do with the switch or the control, and that has everything to do with the loudness tap and so forth that's on, that's in the circuit. It's modifying the signal a little bit, but that's neither here nor there. So you can see we have our volume control, and everything's working. So there you go. That's all it was a simple cleaning. So it tells me that all of these switches are going to need properly cleaned. Now, once you have it cleaned, you want to protect it. So if we come back down to our control, now I will get a residue type chemical such as the Deoxit D5, and I'll just put the tiniest little spray of that in there as a protectant, just a little bit, just like that. You don't need a lot. The problem with the Deoxit is when you spray it as a cleaner, you hose it down so much that protectant gets all over everything, and it gets sticky and it attracts dust and grime. You only want it on the contacts inside there, or on the moving parts. If you soak everything down and it drips out and gets all over the inside of the chassis and everything, it makes a big mess. And it really isn't doing you any good in all those places. That's why you always start the cleaning with a less expensive, just a cleaning agent like this, which this great big bottle is only a couple of dollars. Whereas this tiny little can of this is closer to $15 or $20 US. So you really don't want to waste all this. So there you go, that's cleaned, and now the switch is working perfectly. So we'll go through and clean all the rest of these using the same method, and hopefully we'll be able to get this thing working. Okay, amplifier's plugged back in, it's turned on, and our probes are now back to the input of the main power amplifier. And if we go back over to our scope, let's turn our volume up, and now you can see both channels are properly working, and our dim bulb's lighting up a lot quicker now because both channels are driving. So I know, without even looking at the speakers, I know that there's output from both channels, but we're going to do that next. We're going to look at the actual output of the amplifier now. Okay, so we're back to amplifier testing mode. We're looking at the dummy load output. So we're looking at the output of the amplifier, and if we turn this on, sure enough, both channels. So let's see how many watts that is. So we're at about 2.3 watts per channel right now, and our dim bulb is lighting up. It's not super bright. I can go a little bit more and it'll start to crush the power supply because of the current limiting of the bulb. The bulb's lit up pretty good now, but it's still staying pretty clean. 5.1 watts. See, now you're starting to see the bulb. That's our current limiting. So amplifier's working fine. There never was anything wrong with the amp. It was just the input switching all along. So that was an easy fix. And the good news is we didn't even have to mess around with the preamp. It's working. Now that being said, we can certainly clean it up. We don't know if any bodge jobs are on that. I don't assume anything anymore in this receiver. And probably it could, stand with, replacing the caps. I don't know, because, that affects the frequency response and everything. We won't get into that. Anyway, the good news is the amp is working. Now we can start working on cleaning things up. Now that we have a functional amplifier. And that's my plan of attack. We're going to do the whole amp and preamp section. And then after everything is working properly, we'll go in and we'll work on the tuner. And that'll be our last part of this project. So the next thing on our list that we want to focus on is this power supply. Now, technically speaking, we could leave it as is because obviously it's working. And even though these little vent holes are popped on all these capacitors, so far they've all pretty much tested okay. But again, this is a mess. You can see where this has been serviced. You can see where wires aren't mechanically connected, and I don't like that. So for instance, if I just take my soldering iron here, I bet you if I heat this up, one of these resistors is just going to fall right off because there's no mechanical connection there. So look, there it is. See? It's barely held on there. This, which is your rectifier for the main amplifier, I don't know if this is a germanium rectifier or not. It's very old, we know that. But you can see the two positives, or the two cathodes, are connected together, and they go to your first main filter capacitor. But again, just like we saw on this, if I just heat this up the tiniest little bit, this is just tacked on there. See it? It's just sitting there. It's not even on the terminal strip. It was actually on the leg of this capacitor. So once again, and you can see these have been, it's not long enough to reach. So, and you can see they've added some spaghetti tubing to this to try to insulate it. So I'm not really good with all that. I'm going to remove this really old capacitor or rectifier. We're going to clean this all up. And while we're in there, if I'm going to go through all the trouble of taking all this out and making it right, I am certainly going to put new capacitors in there. They're very inexpensive, and there's really no reason not to do it. Other than to just prove to people that don't like changing caps that you don't really need to. But I don't really have anything to prove, so I'm going to replace them and see if we can clean this up and make it look a little better and more reliable, easier for the next person to actually work on. So we've cleaned up the power supply a little bit. You can see right here. And what I did was I just put a terminal strip in place of that bridge rectifier, or not bridge, the two diodes. And these are in fact silicon diodes, and they were still good, other than the leads being too short. But I replaced them with a pair of 1N5408s. And then the first capacitor, which is feeding the main thing, it was originally 1,000 microfarads. I put two 1,000s in parallel, so that gives us 2,000 microfarad. Why did I do that? Well, the amplifier will work fine as it was designed. I mean, they designed it, and it will work at with the 1,000s. But where this will help a little bit, we have the headroom with the bigger diodes, and the transformer is just fine. But because of the size of capacitors and the cost of them, a lot of times they would use the minimum required for the circuit. When your main filter cap is a little bit larger, and it's diminishing returns, so don't get crazy with this. I've seen people go over the top. But it helps with dynamic range. In other words, when you have a really high transient, this acts kind of like a storage battery, so that you don't have to, those high current pulses don't have to be provided by the transformer. So going up a little bit like this on an older piece of gear like this won't hurt. Now a lot of the later gear, especially the really high-end gear, they have more than adequate capacitor banks. You don't have to modify them or anything. So that's why I made the choice to do this. And if you want to learn a little bit more about this, I did do, it was a couple years ago probably, I did do a video on capacitors like this and about power supplies and how the current, ripple current and so forth. I went through all of that, so check it out if you get a chance. So I replaced these, and as you can see over here, I got rid of that CAN capacitor. I cleaned up these resistors. That one that was over here, the 470 ohm, the lead was really short, and somebody just had it solder blobbed on there. So I replaced it, not because it was faulty, but just because the lead was too short to get, you know, back in there the correct way. That's all the good news. When we connect this and we turn it on, we get our 65 volts, and it's going to go up to 68 when we take the dim bulb out of the circuit. All of our high voltages are good. So there's your 140 volt supply, 150 volt, and 110 is under here, which I'm not getting connected on properly because it's really hard to reach from over here. But there you go. So those are all good. The problem, here is the problem. If we go back over to here and we look at our scope and we turn our volume up, looks good, right? Well, as we keep going up, do you see a problem? Yeah, we're getting asymmetrical clipping on one channel now, and we didn't have that before. Now, the only thing I changed was the power supply, which is totally common to both channels, so I highly doubt that it's the actual power supply here itself. But what I also had to replace were these current limiting resistors, and I didn't, when I went to again clean it up, one of the resistors had a very short lead because again it was solder blobbed on without a mechanically hooking through the terminal strip, and I tried to get it in there. It was just too tight. And then this one had been hot. It's still reading 0.5 ohms like it's supposed to, but all of the coating you can see is just flaking off of it. So I made the choice to replace them. Now I didn't have any 0.5. The standard resistors values now would be like 0.47 and 0.39. I had 0.39s, which will work just fine with these 2N3773s. If there's a little tiny extra bit of current, it's not going to mean anything. Those transistors are way heavier duty. They're about double the power rating of the original stock transistors, so I don't think that'll be a problem. And we can adjust that correctly anyway with our bias, which the bias, I set it, it was not a problem, but we're still getting that asymmetrical clipping. So there's something in here, some wire that I moved or something that is causing that strange clipping problem. So we're going to have to troubleshoot that now. So there's an old saying, show me where you've been, I'll show you where the problem is. So the first things I'm going to go over is everything that I touched. And obviously there can always be a coincidence that something went bad, but I'm very skeptical of that. So that's what I'm going to do next. Once again, show me where you've been and I'll show you where the problem is. Never fails. So if we look here on this right here, you have Q1 and Q2, and at the junction, and then down here you have Q2 and Q3. And if you look at the junction of Q2 and Q3, they both are being fed by your negative 68 volts. So if we look here, this Q2 comes from negative 68 volts through this resistor and into the emitter. So here's your negative 68 volts through the resistor, and look what's on there. There's two wires. And this one marked with the black dot is the emitter. This other wire, however, is the collector of the same transistor. And if you look at the collector of that transistor, Q2, it should be going to the capacitor, and it should also be joining the resistor of Q1. Here's the resistor of Q1. So you can see what happened when I replaced these. Somehow this wire got moved from here over to here. So essentially the emitter and collector of the output transistor are shorted together, which would explain why when I checked, Q4 was getting really warm. Now I don't think it's damaged, but it was getting really, really warm. So if I'd have left it on, it would have probably damaged it. So I need to move this wire from here over to here, and hopefully if we didn't damage anything, it should work. So we have our wire moved, and you can see it's connected. Instead of here, it's over here now. Amp is powered up, have some bias set on it, and let's see what we get now. And look at that. And now the bulb's getting really bright because it's clipping, but you can see it's working properly now. And if we run this right about here, that's about all the amp can handle without the bulb totally limiting the current. It's about 5 watts per channel. Remember, this 118 watt bulb is going to limit the current to somewhere around 1 amp, just a little bit under 1 amp. So, but it's working perfectly now. So we had one mistake, and what do we always say? The wheel was turning, but the hamster was dead. There we go again. So that wasn't too terrible. It could have been a lot worse. So the amplifier's working, and really the preamp is working, although I would imagine it could use being recapped or whatever, but I don't think that's a huge deal. We haven't messed around with the phono stage and all that. We'll do that later. But we're getting closer and closer now that maybe we need to start looking at the tuner, because that's really the next thing we want to check. Well, now the amp has a little bit of hum to it. I have some speakers connected. Let me put you up next to the speaker. And I'm not sure what that is yet, because I have the tuner turned on, and it, although it is really messed up, certainly not sensitive at all, but it is. So this thing might actually work. Unbelievable, isn't it? So there you have it. Now the tuner needs a lot of work, and the amplifier, well, let me turn it on. I have a feeling, oh yeah, if I shut the FM off, the hum goes totally away. I'll put you next to the speaker again. Hold on, let me move the mic. It's very, very quiet. Very, very quiet compared to with the tuner on. So obviously there's something wrong with the tuner, and that could have to do with that mess that we saw in the front end there, with it not being put together correctly and so forth. I did jiggle the tube socket around. Yes, it's a tube, it's not a tube, and it's not a valve here. But we like all references to these thermonic devices, because these are cool devices. But you guys tease me, you got to be able to, if you're going to dish it out, you got to be able to take it too. So just jiggling this tube around here, it seemed to, the filament came on, it's getting warm now, so it's working. The other thing is, of course, redoing the power supply. Now, I did not redo this power supply here. It's all original. And even though these capacitors are all sitting up here, they've all been replaced underneath, except for the decoupling caps for the speakers. And they're working okay right now, and I'll deal with those later. I'm not really worried about it. So, yeah, we're getting somewhere with this thing. And it actually sounds pretty good. I mean, we didn't run into the auxiliary input, but I'm half inclined to do that just to see what it sounds like. I did check it very quickly with the watt setting, and it's a 32, remember it's rated at 32 watts per channel into 8 ohms at 0.9% distortion. So, and it's almost right on that. It just starts clipping on the bottom end, and it clips both channels exactly the same time, exactly the same way. Right when that bottom end clipping comes in, you're right at between 30 and 31 watts. And then once you get into it a wee little bit, you're in 32 watts. It's right on with what it was rated at. So we fixed the amp. So now it's time to move on to see if we can do the same thing to this tuner here. That'd be cool, won't it? So again, I'm going to get this one posted up. Like I said, I'll just do this video here in little chunks because I have the time to edit it right now. But as things get busier, I might go back to the longer video format just because it's all I have time to do. So with that in mind, I wish you all peace, joy, happiness, and good health. And I am sure looking forward to continuing this now. And by the looks at some of the comments there, sounds like all of you are having a good time following along on this. So that's pretty cool. I'm, glad that I can do that. So thank you all, and we'll talk to you soon. And until then, stay well. Bye-bye.